Hey everybody. So here's our lesson for Wednesday, the 15th of April. What we're looking at is section 9.6, properties of logarithms. And we're about done. Friday we'll do 9.7. Next Monday we'll do 9.8, and then we'll test on Wednesday. And we'll test the same way that we tested last time, where I'll do it on Blackboard, and you just complete the assignment on Blackboard, okay? Now, so we'll talk more about that whenever we get closer. So properties of logarithms. I just want to talk about a few things before we start this. So last class we kind of discovered what a logarithm was. And we said, hey, look, we know these exponential functions. We have studied inverse functions. And if you take an exponential and make its inverse, that happens to be a logarithm. So that's what we're studying, are these two special functions that are inverses of each other, and they help a lot with modeling things that grow or decrease exponentially. It's pretty powerful. Now these properties, for them to work, the logs will have to have the same bases. Before we even dive into it, I just wanted to make that point bold and make a bold statement right off the top. I'm going to give you 3 properties today. One of them doesn't really matter about the base, but the first 2 out of the 3 are heavily reliant on the bases being the same. That should sound familiar to you. Do you remember back in Algebra 1 doing exponent rules? Now when we did exponent rules, for those to work, like multiplying things with the same base, they had to have the same base for you to be able to combine them. So that should seem simple. Also, like I just kind of hinted at, these properties will be very similar to exponent rules. I wonder why. Well, wait a second. Logarithms are the inverse functions of exponential functions, things that are built upon having exponents, right? So they are inverse functions, but their rules are going to work very similarly. Maybe just kind of backwards. Just to tease a bit, remember when you multiplied exponents that had the same base, you added their exponents? We're going to have a similar rule where if you're adding 2 logarithms, you could probably guess they relate somehow with multiplication. It's just the backwards kind of the rule. So let's dive into our first property. Our first property is the product property. Okay, and here it is. Notice there's no numbers here, it's all letters. But here's what it says. And this can go either way. It can go, you can break it apart and go that direction with it, or you can put it back together and go that direction. So these properties are two-way properties. You can use them for either way. And in different times, it will be useful to smush 2 logs together or to break 2 logs apart, depending on what we're doing. I want you to notice something. Whatever the base is here, notice it doesn't change. And if we're going this way, to put these 2 together, they need to have the same base. So look, if 2 logs are being added and they have the same base, I can re-represent them as a single logarithm, that same base, where the inputs are being multiplied. Okay? So all the properties I'll show you today can go both ways. So as far as examples go, here's our first example. Let's go this direction. Notice I have 2 logarithms being added. And what do you notice about the 2 bases? The bases are the same, right? Same base. Same base. So what that means is, since we're adding these 2 logs, the property says that I can put them in a single logarithm with the same base. And what I'm going to do is I'm going to take those 2 inputs and multiply them. Okay? And then I can actually do the multiplication now. Everybody know 2 times 3 is 6, right? So log base 11, 6 is the same thing as log base 11, 2 plus log base 11, 3. Okay? So we wanted to write it as a single logarithm. Now if you think about this, it's kind of the opposite of exponent rules. With the same bases being multiplied, you added the exponent. With the same bases being added, you multiply the inputs. Just pointing that out again, sorry. I love all the connections. I know some of y'all are like, Just teach me the rule and let me go. Some of you love digging deeper. I just want to give the full wealth of all this. All right, so let's do one where we go the other way. So this is a single logarithm. Can I write it as a sum? That means an addition, right? Can I write it as a plus sign of two logarithms? And the answer is yeah, because what's in between the 3 and the x? That's a multiplication, or a times, right? So the rule says that I can break this into an addition of two logs as long as the base stays the same. The base is 5, so both of these are going to be base 5s. And the input is 3 times x. So I can make it 3 and x, where I'm adding these two log base 5s. Okay, very simple rule. You can go back and forth. You can break apart, or you can smush together. Okay. All right, let's go on to the second rule. These are not real hardcore rules. At this point, your level of math knowledge has grown so much that these are just should not be overly intimidating to you. So look at the second rule, a quotient property. Remember, quotient means like a division property. You could probably guess it. It's going to be very similar to the multiplication, the product property that we just did. The product property related to additions. Quotient property. Quotient is kind of the opposite of product, right? So it probably relates to subtraction. So let's take a look. So this says, look, same base, same base, same base. That if I have a quotient, a division, here I have x divided by y, I can break them apart into two logs. Now instead of an addition, it's a subtraction this time. Okay? Or I could go backwards with it. I could say, look, two logs with the same base, they're being subtracted. I could smush them into a single log with that same base being divided. So let's do an example going each way. 2 examples. So this one says write as a single logarithm. So here they notice what's the big key? They have to have the same base. Now what operation's happening in between them? Just in case I was mean and put an example that did not match. It's a subtraction. So that means I can squeeze these logs, because they have the same base, into a single log. And the relationship between the inputs, 27 and 3, will be a division. Now let me ask you a question. Does order matter? That's my question. Does 27 divided by 3, is that the same thing as 3 divided by 27? And hopefully you're screaming no and throwing things at your computer screen right now because you're angry that I'd even ask. But 27 divided by 3 is 9, right? 3 over 27 is 1/9. Very different. If you have $9, you can go and take your friends to McDonald's off the dollar menu. If you have 1/9 of a dollar, you can't even go buy yourself something off the dollar menu. That's not even a whole dollar, so not even. So order is important. Notice the one that goes on top was the one that was first. 27 over 3. 27 came before 3. Now 3 is kind of sloppy. There we go. Now does this reduce? Yeah, we already did it over here. 27 over 3 is 9. Awesome. Okay, so let's scroll down and let's do another example where we go the other direction. Can I write this as a difference of logarithms? Notice I have the log base 9 of x over 7. So notice this is a division. So I'm going to break it into two logarithms. Both are going to keep that same base of base 9. What operation is going to be in between them? A subtraction, because this is a division. Now what's the first input going to be? Whatever's on top, which is x. And it's x divided by 7, so 7 is going to be the second input. Okay? So that's all we're doing, is putting things together and breaking things apart. This is giving you an ability to manipulate logarithms. And if you can manipulate them, you can make them fit whatever use you need to do. Like if you're trying to solve for x and you really need to get x by itself, we could manipulate this to where we could start working on getting x by itself without too much labor. Or, or if you're trying to type something in a calculator and you can smush it into a simpler input. There's lots of different usages for being able to go back and forth here. Okay, one more property. It's called the power property. Well, we also had a power rule in exponents, right? This one's going to be kind of, similar. So it says, look, if I have a logarithm and the input, Notice right here the input has an exponent. What I'm allowed to do is take this exponent, and it's allowed to jump out front. See what it's equal to? Log bx, and that r has jumped down out front as a multiplication. So I'm able to take the exponent that's on the input, and I'm able to move it out front as a multiplication. That's actually really useful when we're manipulating and moving things around, especially if you're trying to solve for x or solve for something. It kind of saves a lot of stress if you're able to do that. Okay, so I would say let's do an example and practice it, but that's not very hard. So let's look at this one. So everything is going to stay the same. It's still going to be log base 5. And the input's still going to be x. It's just that 3 that was an exponent on the x is going to jump out front as a multiplication. So 3 times log base 5 of x. So let me show you an example maybe where it's a little more useful right off the bat. Log base 4 of the square root of 2. That's kind of messy, right? And you're like, well, we don't know how to simplify that, but you actually do. Remember something. Remember that the square root of 2, I can write square roots and such radicals as exponents. Remember what the square root is as an exponent? That's the half exponent. We learned that earlier in the course. So I could rewrite this as, instead of square root of 2, as 2 to the 1/2. So that's an exponent, right? So then I could simplify further by taking that exponent and throwing it out front as a multiplication. So a half times log base 4 of 2. Alright? So that's pretty awesome. That helps us manipulate a lot of things. You'll see over the next few sections where some of these may come in handy for solving and such. Okay? So now let's just do a last little bit. Almost done. We're going to try mixing all these properties together. So the first few I want you to write as a single logarithm. So look at this one. We want to write as a single logarithm, so we want to put everything back together. Well, the first thing you should ask before we even attempt it is, do they have the same bases? And the answer is yes, they have the same bases. So we're good to go. Before I deal with this plus sign, notice they have, let's change colors here, make it pop. Notice they have numbers being multiplied out front. Well, according to the last rule we just learned, I could take this 2, remember we could work those laws both ways, and put it up here as an exponent. And the same thing with this 3, I could put it up here as an exponent. So let me write out what we'd have. Log base 5 of 3 squared plus log base 5 of 2 to the 3rd. And it so happens, just some scratch work, I know 3 squared, that's 9, right? I could simplify that. I also know 2 to the 3rd, that's 2 times 2 times 2, that's 8. So we could simplify this a good bit. So we could have log base 5 of 9 plus log base 5 of 8. So let's see, they have the same bases. Now they already look a whole lot simpler. Have the same bases. We're adding. So what does that mean? I can smush them into a single log base 5. And what do I do with these two inputs, 9 and 8? The rule says I multiply them. So there I go. I'm pretty much finished. Let's do the multiplication. So log base 5 of 72. Awesome. So that is definitely a lot more simple than what we began with of all that mess out there. Okay, try another one of these. So once again, I want to combine this into a single log. I see the 3 out front, so I'm going to go ahead and just start with those exponents and fix those exponents. So log base 9 x to the 3rd, since I'm moving that 3 up front, minus log base 9 of x plus 1. Now there's no more exponents to fix. Do they have the same base? Yes, both of them have the same base. Look at what operations in between them, a subtraction. So that means I can smush these together into a single logarithm with that same base 9. But what way are they going to relate? There's a subtraction here, so that means they're going to be a division here in a single log. What goes on top? x to the third. What will go on the bottom? X plus 1. So I have compacted this down to a single logarithm, and it looks beautiful, right? Okay, awesome. So can I go the other way? Can I take a single log and stretch it apart? The answer is yeah, I absolutely can. So look at this one. Notice I got things being multiplied here and something being divided. Let's take care of the division first. So I can break this division. I can break that into log base 3 of 5 times 7 minus log base 3 of 4. Now can I break this part up? And the answer is yeah, that's a multiplication. So that'll break up into log base 3 of 5 plus log base 3 of 7. Now don't forget to bring down the minus log base 3 of 4. So I can rip apart these logs as well. Sometimes that serves a pretty nice purpose for us, you'll see later in this chapter. Let's do one more with x's and y's. Can I rip this one apart? And you say, well, there's only two things here, x to the fifth divided by y squared. So that would turn into log base 2. Remember, we're keeping the same bases, log base 2, and it would be a subtraction since that's a division, right? So x to the fifth and y squared. Now there's one more thing I can do to these. I can move these exponents out front, right? So 5 log base 2 to the x minus, let's take the 2 out front, 2 log base 2 to the y. So I've ripped this apart as much as I possibly can. Okay? And so that's all I have for you today. Make sure you try the worksheet. The answer key will be attached as the second page. So don't look, but try that and then check once you're finished. And we're getting close to a test, so make sure you're watching your videos and emailing me any questions you may have. All right, y'all have an awesome night.